Okay, today's lesson is section 6.5, but day 2. There are 2 warm-up activities that we're going to do here. The learning target is the same as yesterday. However, with these 2 warm-up activities, I'm going to go ahead and give you a little bit of time to try them on your own. So why don't you go ahead and hit pause right now and take a little bit of time to do it. And when you return, I'll walk you through the process of how to arrive at the solutions. Okay, the directions are asking you to graph the solutions of the linear inequality, or inequalities in this case. So remember, we're going to be drawing a picture of what all the solutions are. So we know from our previous knowledge of equations of lines, looking at the first one, we can see that it's in slope-intercept form, which means we're going to start the graph by drawing a point at the y-intercept, and the slope is 1 over 1. So from that point, we're going to go up 1 and over 1, then also down 1, back 1, down 1, back 1, and so on and so forth. And we're then going to go ahead and graph the line. Since it is an inequality here and we have the equal sign underneath the inequality, we are going to go ahead and do a solid line connecting those points. And it would look like this. And remember, we do need the arrows on either end, so I'm going to go ahead and darken those. Now, that's a picture of the line itself, but for the inequality, we need to shade in the region that satisfies all the answers. The way we do this, if you remember, we go ahead and substitute 0 and 0 in. In other words, we're going to take the point that's at the origin and see if it truly is a solution. So when I put 0 in for y and put 0 in for x, I end up getting this statement. 0 is less than or equal to 4. That is a true statement, which means the side that contains 0, 0 represents those solutions. So I want to go ahead and shade in that side that has the 0, 0 in it. So this is what your final graph would look like for the first one. Now, for the second one, exact same idea. The only difference is this one does not have it in slope-intercept form first, so we're going to have to work to isolate the y a little bit. I'm going to do the work up here just so I have a little bit extra space to do that work. And the first step in that process would be to go ahead and move the x over by subtracting it. And notice I don't need to write the plus 0 here, which is simply a negative x on the right-hand side. And then I need to continue to isolate that y by adding a 1. That will cancel things there, leaving us with a final inequality of y is less than negative x plus 1. So again, now that it's in slope-intercept form, I can start with my y-intercept of 1, and my slope is a negative 1 over 1, so I'll be going down 1 over 1. Down 1, I'm sorry, mistake there. Down 1 over 1, continuing with that pattern. Now this graph does not have an equal sign under the inequality, so it's going to be a dashed line when I go to draw this. And it would look like this. But again, we're not finished because it's not a linear equation we're doing, it's a linear inequality. And I need to figure out what side to shade, so I'm going to go ahead and substitute 0, 0 into the original equation. So we'll put a 0 in for this x and a 0 in for this y, and that would leave me with a negative 1 is less than 0. That is a true statement. So I do want to go ahead and shade in the side that contains 0, 0. I'll go ahead and do that right now. 0, 0 is on this side. So this is what your final graph would look like. Okay. So hopefully you did well with those 2 warm-up activities. We're now going to transition into the newer material. It's actually the same thing we just got done doing, but kind of in reverse order. Instead of giving you the inequality and asking you to create the graph, we're going to give you the graph and say, okay, let's work backwards here and figure out what the inequality would be. So when we write these, for starters, we always want to write them in slope-intercept form. So we're going to have a y, we're going to have some sort of sign here, we're going to have our x, possibly with a coefficient in front of it, and then sometimes, plus or minus whatever the y-intercept is. So that's the form we're working towards. And looking at the graph, let's go ahead and bring the y down. For starters, I see that we do have a y-intercept of negative 2. So I don't know what the inequality is just yet, but the negative 2 I'm going to go ahead and write as this. In other words, I'm filling that in to this space. Okay. I also need to figure out what the slope is, and looking at the graph, I see I can go up 1 and over 2, so that would be a slope of 1/2. So I'm going to go ahead and fill that in as my coefficient in front of the x. The only thing left to determine now is the inequality sign. Okay, well, since the side that contains 0, 0 is shaded in, I know 0, 0 has to be a solution. So I'm going to go ahead and just kind of guess here and see what, let's see, if I put 0 in here and I have this, I'd end up with 0 and a -2 on this side. So 0 is actually greater than -2. So that's what my symbol is going to be right here. Because it's a solid line, I do want to go ahead and put the equal sign underneath. So that, in fact, is my final answer. I'd have the inequality y is greater than or equal to 1/2 x minus 2. Meaning we have the y-intercept here at -2, and our slope was up 1 over 2. And 0, 0 was a solution when I substituted it in, so I had to go with the inequality greater than or equal to. So that would be your final answer. And essentially all the problems are done this way. So we're going to work through a number of examples, starting with this next one. Same idea. We're trying to set this up. So I see that I have a y-intercept. I'll go ahead and change colors up here. Y-intercept of +1, so that's going to go in that position. It'll be a +1. I also see that my slope, it looks like I'm going up 3 and over 1. So that's going to have a slope of 3. And again, I'm just trying to figure out what my inequality will be. Well, it's a dashed line, so I know I'm not going to have the equal sign underneath. But let's go ahead and plug in 0, 0. And again, notice we know that 0, 0 needs to be a solution. So when I substitute that in, I get 0 on this side, and I get a +1 on this side. And 0 is, in fact, less than 1. So I'd want to go ahead and use the less than sign when I write my final answer. So again, this is what we'd have for our final answer. Well, again, y-intercept of 1, a slope of +3, and less than for our inequality sign. Now the next example, a little bit trickier, but it's also kind of easier at the same time. If you think back, when we were learning about graphing linear equations in Chapter 5, when we had a horizontal line, we know something just like y equals, and in this case it would have been 3. So I know my answer is going to look something like this, but remember it's an inequality with a whole bunch of shaded in region down below. Well, since 0, 0 is a solution, and really just with some common sense, if you think about it, any point down here in the shaded region represents a solution. And if you think about the ordered pairs that go along with all those points, every single one of those ordered pairs would have a y value that's less than 3. This y value would be +1. This y value would be 0. This y value would be a -2. This y value would be a -4. So essentially what we're saying is any y value less than or even equal to 3 is a solution. And that's what this graph represents. We're saying any point down here, the y value is less than 3 or equal to. Now, continuing with the same line of thinking, this is another one of those special cases. When we have a vertical line, back in Chapter 5, we learned that this was x equals, in this case, would be a -2. Well, again, since we have shaded in region, we want to go ahead and create it as, or write it as an inequality. And kind of using the same logic as the last problem, if you think about any of these points, including 0, 0, every single x value in that shaded region has an x coordinate that's greater than that -2. So that's essentially how we want to describe these solutions. X is greater than or equal to -2. And again, the reason we need the or equal to is because that's a solid line, and any point on that line does represent a solution. A couple more examples to go ahead and get through here. For this one, exact same idea. I'll go a little bit quicker. We know the y-intercept is 0. So I'm going to put +0 for right now, but I know my final answer, I won't need that. My slope, it looks like, is down 1 and over 1, so it's going to be a slope of -1. So I'm going to kind of clean this up a little bit. Right now, this is really all I'm going to need, because again, I don't need the 0 there. I just have to figure out what the inequality sign is going to be. Now, typically, we would use the ordered pair 0, 0, but that's not an option because the line goes through there. So I'm going to pick another one that's easy to use. I'm going to go ahead and go with -1, 0. Now, it's in the shaded region, So I know it should work when I put -1, 0 in. So when I put the 0 in for the y and the -1 in for the x, I get 0 here and 1 here, and 0 is less than 1. So I have to go with the less than sign right here, meaning my final answer would be y is less than -x. So again, same idea as all those previous problems, but we can't use 0, 0 as our test point. And then finally, the last example like this, once again, it's like the ones we've been doing. We're going to start off by setting it up like this. And it looks like my y-intercept is down here at -3. So I can fill in this much. It looks like my slope is, I'm going to pick this point here and this point here. So I'm going down 2 and over 1. So that would give me a slope of -2. Once again, I simply need to figure out what to put in as far as my inequality sign. So I'll use 0, 0. And 0 is greater than -3, at least the last time I checked. So that's the sign we're going to go with. But keep in mind it is a solid line, so it's going to be an equal sign underneath there. So that's essentially our answer, but I'll write a nice clean version of it. We have y is greater than or equal to -2x minus 3. And there's the answer for that. All right, well, hopefully you've mastered those previous 6 problems. We now have one last problem to do here in this section. We have the problem, Trey is buying peach and blueberry yogurt cups. He will buy at most 8 cups, so that's very important, of the yogurt. And they're telling us to let x represent the number of peach yogurt cups. And with red here, it looks like they're saying y represents the number of blueberry yogurt cups. Okay? And they're asking us to write an inequality to describe the situation. So what it's essentially saying is that the number of peach yogurt cups plus the number of blueberry yogurt cups can't be any more than 8. It can be equal to 8. It just simply can't be any more than 8. Okay? So right now it's in standard form. We could go ahead and graph it that way. Or if you wanted to, if you're more comfortable with slope-intercept form, you could take that equation and you can subtract the x from both sides, and you can create this equation. Okay? We do need to label our graph, so the title of the graph would be Ways to Buy Yogurt. And there really isn't an independent or dependent variable, so I'm just going to go ahead and put the number of blueberry yogurts on this side. And I'll put the number of peach down here on the x-axis. And we'll go by ones. You really don't need to label it if you're going by ones, but to make things a little bit easier, I'm going to go ahead and do that. And it says to graph the inequality / solutions here. So we could either use the cover-up method and get the ordered pair 0, 8 and 8, 0, or you could use the slope-intercept form of the problem we created. Start here at at 8, and we can go down 1 over 1, down 1 over 1. Regardless of how you chose to do this, you'll still get the exact same graph. So let me go ahead and draw that in there. And it would be a solid line since we have the equal to and we're including the number 8. So that's the graph of the inequality, but we do need to shade it in. And I'm going to do that by testing 0, 0 and just mentally putting it into the original inequality. When I do that, I get 0 is less than or equal to 8. So that means I do want to go ahead and shade in this region here, because that represents all the solutions that would work for this particular inequality. And the last part of this said to go ahead and give 2 possible combinations of peach and yogurt. Well, any point in here would work. So that would be, what, 5 blueberry and 1 peach. And I'll just randomly pick this one. That looks like 2 blueberry and 5 peach. But again, any point in that shaded region would represent a possible combination of yogurts that Trey can buy. All right, hopefully this video helped. Good luck with your homework.